Welcome back. So we're looking at number 1. The reflector inside a car headlight is built in the shape of a parabola. The shape of the reflector is shown by this equation, where y is the vertical distance from the tip of the light bulb in millimeters, and x is the horizontal distance from the tip of the light bulb in millimeters. So we better define a few things. We better talk about this being the light bulb. The rest of this is the reflector. The equation is for this parabolic shape of the reflector. We need to put in the x-axis and the y-axis. We need to be careful how we do this, because if we put it in wrong, then our equation won't make sense. The reflector of a car's headlamp is built. The reflector is shown where y is the vertical distance from the tip of the light bulb. So y is a vertical distance from the tip of the light bulb. I would say that's a tip of the light bulb. So y is going to be a vertical distance from the tip. This is a vertical distance. Now, if it's a vertical distance from the tip, we're going to have to decide one way being positive and one way being negative. And we might as well throw that in right there as our x-axis. And what that allows us to do is this direction is positive distance away from the tip of the light bulb, and this direction is negative distance away from the tip of the light bulb. So now the question is, what does the x-axis represent? The x-axis represents the horizontal distance from the tip of the light bulb. So this is horizontally from the tip to the right and horizontally from the tip to the left. You are going to be responsible for setting up these axes. This is important. Now, on a side note, why do we care? Well, this light bulb, if you remember from physics, or if you have an understanding of how light works, it's going to be shooting off light rays this way. But it also shoots off light rays this way, and it also shoots off light rays this way. So what we've done by engineering this headlamp so that it is parabolic in nature, when this ray of light hits the reflector, it actually is going to be sent out like that. And when this light ray hits the reflector here, it's actually going to be sent out like this. Which means having a single light source here will take all of the light that's coming from that light source in all directions and redirect it straight out. That way we can see the road and oncoming traffic, and they can see us far more efficiently with much less light, because we're getting all of that light going in the direction that we want. So that's a little bit of a discussion on the engineering of this. Calculate the Y-intercept. Mark this on the diagram. Well, the Y-intercept is where we're going to be crossing the y-axis, and that's going to be right here. It's also going to be your vertex, but it's also the y-intercept. So, y-intercept. And it is at the other end of the bulb, if you will. So there's your tip, and there's your end, or other tip, if you will. So, calculate it. Well, to be able to calculate it, what I'm going to do is I'm going to set x equals to 0. I'm going to take the information that they gave me about this reflector, which is y equals x plus 40, 0.03x minus 1.2. And I'm going to set x equal to 0. So what that's going to be is 0 plus 40, 0.03 times 0, it's a 0, minus 1.2. This is still multiplication, so it's actually 40 times negative 1.2, which is going to be an answer of negative 48. So this y-intercept is going to have the coordinates of 0, negative 48. Calculate the x-intercepts. and then mark them on the diagram. So what we're going to do is we're going to set y equal to 0. And they're going to show up here and here. These are my x-intercepts. And in this case, there's two of them. One is on this side of the light bulb, the other one's on that side of the light bulb. So when we set x equals to 0, y equals to 0, we're going to end up with 0 equals x plus 40, 0.03x minus 1.2. Now this one's pretty easy. I've got two things that multiply to give 0, which means that one of them has to be 0. We talked about that in the last post. Please go back and see that video about the 0 principle if you need to. But there's two things multiplying together to give 0. So one of them, or both of them, has got to be 0. So either, now this one's pretty easy. What's going to make x plus 40 equal 0? Well, it's negative 40. So I can do that one in my head. But this one's harder. So I'm going to use the math to help me. I'm actually going to write out the equation. I'm going to take the 1.2 over to the other side. I'm going to divide both sides by 0.03. I'm going to use a calculator, and I'm going to find out the answer is 40. So what I have here is this point is going to be negative 40, 0, and this point here is going to be positive 40, 0, meaning that this distance is positive 40, this distance is negative 40, just indicating it's in the opposite direction. That's what the negative means at this point. How tall is the light bulb? So they want to know this distance. Well, that's going to be 48 millimeters. And yes, you need to put in the units. You get that by going back to the question. How wide is the reflector at the tip of the light bulb? So that's not how wide is the reflector here, or even down here, but at the tip of the light bulb. This is the tip, right there. So that's going to be 40 millimeters that way. It's going to be 40 millimeters that way. So 40 millimeters to the right plus 40 millimeters to the left is going to give us 80 millimeters total. That's it. Okay, I'm going to stop here and we'll do the next example in just a moment.